Hello, everybody. You are listening to Through Time and Clades. My name is Albert.
And I'm Joan.
Fantastic. So, today it is, oh gosh, it is already December of 2021. I think the year just flew by for me. I don't know about you, but yeah, gosh, I can't believe we're here already.
It has flown by. I'm definitely trying to take it a day at a time,
Mm-hmm.
because I don't know. I feel like the whole thing about this year has flown by thing. I mean, it kind of gets us moving way too fast.
Mm-hmm.
We kind of forget to stop and appreciate the time that we have,
Yeah.
and if we just kind of keep anticipating oh, it's going to be January, then it's going to be 2022, and oh my gosh, um, but I don't know, because that's always felt kind of weird to me. I mean, because it's all fairness on your end, of course. It's like oh, I can't believe it's December, but at the same time, it's like oh yay, it's December because then it's the holidays and there's a lot to look forward to.
Mm-hmm.
Um, so yeah, I guess there's that.
Yeah, no,
Um,
I think it is good to have a positive outlook on these things. Um, at least in my case, I think it's definitely a bit influenced by the fact that I'm kind of in the final year of my PhD, so I've just been kind of busy, 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 busy all year, and um, yeah, so I guess things kind of feel like they rush by, but there's been a lot to enjoy despite everything, um, and since it is the beginning of the month, we have another news episode where we're technically looking at new material, but we're kind of looking back on the previous month and not so much worrying too much about how fast things are moving. And so no, I think this is nice. And speaking of finishing my PhD, so on my end of things in terms of currently what I'm up to. Um, I am more or less finished with preparing my thesis. So the next step for that will be to send that to my supervisor and he'll provide some comments. And then after that, I'll be able to submit it to the university and then I can have in my examination and hopefully I'll pass. But yes, so basically the busiest part of the thesis is I'm pretty much done with that. So I am pretty excited about that, but also a little nervous because I kind of start worrying about, oh no, what if I got this wrong or I left this out or, darn. But in any case, I guess that's one of the reasons why I sent it to my supervisor first, so he can catch some of those problems if there are any. Um, Now, yeah, so with that, I am definitely looking forward to getting to do other things I want to do, including working on our website. Yeah, we we are still working on that, and actually, believe it or not, I actually did write a little bit of material for the website quite recently for the dinosaurs, the second chapter portion. So yes, we are still plugging away at that, and with my thesis soon to be submitted, I think I'll be able to devote a lot more time to that, and hopefully, you know, we'll be ever closer to a complete website we can show all of you guys. Um, so yeah, that's probably the biggest event on my end. What have you been up to?
oh well, just kind of preparing for the holidays. We're gonna be doing Christmas with my sister Julie this time around,
Oh,
so we're gonna go
nice.
to Charlotte, and it'll be nice because we they live about 6 hours away from us, so there's no oh, let's just go for the day and then come back.
Right, right.
We have to really plan these things really well, and so we were able to get some time off and in the week of Christmas to go and celebrate with them and just catch up and have some fun and just enjoy the time together, which I'm definitely looking forward to. Um, let's see. I know pop culture wise, there's been a lot of fun things that have been coming out lately.
Mm-hmm.
All you MCU fans out there must be excited about Hawkeye.
Oh, right.
And I've been looking forward to that. And so I'm about 3 episodes in. Well, we're about 3 episodes in now, because of course I started watching all the Disney Plus shows after the fact,
Hmm.
so I was able to kind of get them all in one go,
Right.
which is fun because like they're kind of like big extended movies. But this is actually the first time since What If where now I'm just kind of waiting for them to continue the story. And a lot of exciting stuff. I mean, for one thing, like, oh my gosh, how long had it taken for like one of the last of the original Avengers to get their own
Mm.
property? I
Right.
mean, it's not a movie, but hey, it's a TV show, and so like that's still pretty exciting.
Hmm.
And it was kind of fun, like a little bit of personal family history here. One of my other sister, Gabby, one of her friends from high school that they haven't. It's been a hot minute since they've spoken. Life and whatnot. Adele Drehost. So if you notice in the credits of episode 2, there's a character called Missy, and Missy is played by Adele Drehost. So Adele had these aspirations to be an actor and had done like little bit parts here and there. But this is now her first like major production. Like she's in Hawkeye, not as a background character, but as like a legit character who gets to talk to Jeremy Renner and plays a role in the plot. And it's like, oh my gosh, like what a small world. Like
Hmm.
this is somebody that we knew growing up, and look at them on the big Disney show now. Like that's just kind of been exciting to find out. And I mean, I didn't know about it until Julia texted me like, "Hey, do you remember Adele?" And I'm like, vaguely. And it's like, "Well, she's on Hawkeye." And I'm like, "What?" That was kind of like a fun surprise. 'Cause, yeah, I did like. I was in high school, long after Gabby had left and graduated, so I was never like with her group. But I did know Adele from like outside things,
Hmm.
and so it's kind of fun to see that. So really exciting. I definitely like the show so far. Um, Looking forward to seeing where the plot is going to go. But probably like the bigger pop culture news on my end is that I got to go see Encanto
Mm.
on Monday, this past Monday. So this is the 60th animated film by the Walt Disney Animation Studios, set in Colombia. And oh gosh, it's a good one.
Hmm.
It's a really good film. I had high hopes for this because with their last film, Raya and the Last Dragon, which was their Southeast Asian film, um, I liked it,
Hmm.
but unfortunately, there were story issues and character issues that I had where it just was not very memorable to
Yeah.
me. Like I watched it and I let kind of the weeks pass and trying to think back to like things that had happened in the film, and not a lot really jumped out at me, which is a shame because the premise is cool and the world building is cool and like the side characters are wonderful, more so than the main lead, which is interesting. And you kind of want to see more of that,
Hmm.
but because this is a film and not a television series, you can only get so much
Right.
without the film being over bloated. So there was a lot to be desired with Raya and the Last Dragon. But with Encanto, my hopes were raised very high and like they were very much succeeded. The plot is wonderful. The Madrigal family is a delight. They are such wonderful characters to get to know, and they're used in just the right way, where you get enough time with them, and it doesn't feel overbloated.
Hmm.
Because let me see. So you have Abuela. Okay, you got 3 kids. You got their husbands. You got 1, 2, 3, 4, 5. There's over like 13 characters in this movie
Wow.
to keep track of.
Yeah.
But it's like, but like it doesn't feel overbloated. Like there's just enough time to get to know all of their personalities,
Hmm.
and you fall in love with all of them. Like they're they're so great, and they have such wonderful powers. Because if you weren't familiar, the story kind of takes a Solitude of a Thousand Years sort of vibe, where it's the real world, but there's like magic kind of casually thrown in, and it's
Hmm.
not like a big deal. There's
Right.
no like wizards or witches or anything. Like it's just, oh hey, these are people and they have powers. Cool, and let's eat.
Yeah.
It's
Right.
just it's
Right.
very very casual. And so the kind of the premise of the film originates in the past. with the abuela and how she kind of like founds the home and the family. So, without giving too much away, Colombia's history, which admittedly is a bit of a blind spot for me. I mean, when it comes to like I guess post-Columbian Latin American history, I would like to know more, but it is one of those regions of the world where, and one of those time periods where, in your like conventional world histories, like they kind of get sidelined. Like, okay, you have the periods of colonization and then the wars of independence, and then they kind of just drop off the radar the
Mm.
closer you get to the present day, with just kind of a casual aside, which is not fair, because I mean it's a whole continent and there's a lot of rich history there that I'd love to explore more. So I've been slowly doing that, and so what I learned, of course, Colombia has a rather charred history of civil wars. Lots of civil wars where people are killed and are exiled and are moved to and from, and a lot of political upheaval that goes on.
Mm.
And so, like, the film opens with one of these situations where the Madrigal family, or at least like the root of that family, is forced to flee from violence. And of course, for me, it's like, okay, when exactly is the film supposed to take place? Because it's like they don't throw years out or anything like that. Like they you're kind of left to pick up the pieces on your
Mm.
own. And thankfully others have done that.
Hmm.
And so it seems that this initial opening of the film takes place at about the turn of the 20th century. So in Colombian history, there's the War of the Thousand Days, which was between 1899 and 1902. This was a civil war between liberal and conservative factions, which the conservatives won, by the cost of like widespread destruction and the deaths of over 100,000 people. So it was not a good time, to put
Mm.
it blunt. And so it seems like in this context is when the film opens up. And of course, like the house is built and the family's established, and then 50 years passed. So like the rest of the film seems to take place in like the 50s and 60s, which is cool. It's kind of nice to see a sort of modern Disney film, but like not contemporary.
Yeah.
Because like I think about, Oliver and Company. Yeah, like when that movie came out, like it's supposed to have taken place like at the time that the movie came out,
You're right.
in the late 80s. So like you're living in the late 80s and you're watching this film, and oh look, the characters are there in the late 80s. Like you could walk out the movie theater, go down the street, and there they are hanging out, these
Mm.
dogs. So like this is kind of a nice change of pace to see sort of like a maybe like this would be within my mother's like early
Mm.
lifetime. So like that was kind of sweet to see. And yeah, just like the rich culture of everything, like the colors, the soundtrack is a banger. They got, who else? The world's most famous Puerto Rican right now, Lin Manuel Miranda, to
Mm.
come and do the score, for all you Hamilton fans out there.
Mm. Mm. Mm.
Um, and you know what? I've watched this film twice now, and initially I was a little bit on the fence about Lin Manuel's music because he has a very particular style that once
Mm.
you hear it,
Yep. Mm.
you can kind of like tell like, oh, this is a Lin Manuel song. It's very poppy, lots of lyrics. Um, and like I was initially on the fence about it because it felt a little out of place for a film like this.
Yeah.
Like I wasn't really connecting with a lot of the songs. Um, but by the second time around, I ended up really connecting with the songs, really liking the lyricization of everything, and how it's laid out through the movie. And that's really good because if you're going to do a big Disney musical, you got to make sure your songs are legit. And oh yeah, like when you're humming these songs like hours after the fact, and looking them up on YouTube and listening to them again, it's like, yeah, good music, great music. So yeah, definitely, I highly recommend going to see Encanto. It could definitely use the support. I know it's kind of in a precarious situation right now
Mm.
because this is still technically pandemic time, and we got another variant out there that's already hit the states.
Yep.
So nobody's really like jumping up and down to go back into a theater again. Um, and of course, like the fact that they had to release Encanto now means that it is at risk of succumbing to the pandemic.
Right.
Like poor timing. Um, at the time that we're speaking, the film has made at least over $77 million in the box office, but the budget is between 120 and $150.
Mm,
So they still got a bit of a ways to go. And I know they're already planning on dumping it on Disney Plus by Christmas Eve, I believe. And I don't know if they're going to just put it on there or if they're going to make it exclusive access for a little bit to kind of help with some of the funds. I guess it really depends. Um, but that always kind of worries me too, because usually higher ups see a movie failing at certain times, and they think that, oh, it's the movie that's to blame, when in
right.
reality it's just the timing. I
Yep.
mean, you don't have to go very far in Disney's history to see this sort of thing happen. I mean, when Pinocchio and Fantasia came out, they were like flops, and a big reason for that was, oh, by the way, World War II is happening.
Right.
And you lose your European markets, and nobody's wanting to go to see these films when there's tremendous human rights violations
Right.
being done. So they kind of had to wait for their stardom to shine. It wasn't until like the 50s or 60s when these became classics. So I don't know. I don't know how Encanto is going to do. All the reviews have been fairly positive, so I
Hmm.
don't think that this will be a panda movie in that sense, where it's going to have to wait years to be popular. I mean, I can tell it's already popular right now. A lot of people are talking about it,
Hmm.
um, but it definitely needs a little bit of help. And I'm fingers crossed. It's only been like 2 weeks. Maybe things will look up.
Hmm.
Who knows? But I definitely just the close. I definitely enjoyed Encanto, one of my favorite of the recent films in a while,
Hmm.
and I'm excited to watch it again, and I'm excited to share it with people, and I think it's just great. So go check it out.
Fantastic. I am definitely excited to see it eventually when I can, um, and I'm really glad to hear that you enjoyed it so much, and I'm also glad to hear that they were able to handle the huge cast very fluently because that definitely was one of the things I was a little bit skeptical about. Like I saw the trailers and they looked lovely, but yeah, the thing is like having a ton of
Mm.
characters is often very tricky from a writing standpoint, and you often get cases where a lot of them don't really stand out or get their chance to shine or anything like that. But no, it sounds like they were able to do it brilliantly. So I definitely look forward to that. Um, and speaking of pop culture stuff, like the thing is, finishing my thesis, or at least soon to being soon to submit my thesis, I and freeing up a little bit of time for myself means that I'll finally be able to catch up on a lot of the pop culture stuff that I claimed or wanted to. Um, yeah, because in fact, I don't think I've seen like maybe a new movie since I don't know in like over a year or something. Like I think probably the only like new movie I've seen um, recently is the My Little Pony New Generation movie, which is available on Netflix. So of course I can watch it from home. Um, but yeah, like pretty much everything else I've kind of been putting on the back burner. So yeah, I'll definitely try to make good use of my additional time now and catch up on a lot of things I want to watch. Yeah, and definitely I think as soon as it's convenient for me to do so, I think Encanto would be near the top of the list in terms of what movies or shows I want to check out. So yes, I look forward to seeing it for myself too. Alrighty, so I guess if we don't have anything else to add, should we continue on to our news stories?
Sure, let's do it.
All right. Let's have a go and head to the next slide. All right, so I guess the first story is one of mine. And so for my first story, I decided to pick one about a new dinosaur. Very original to me, I know. This is a um, well, I picked this one because it really is a very weird new dinosaur. In fact, I would consider it one of the most unexpected and interesting new dinosaurs to have been named this year so far. We do still have about a month left for something to top it. And technically, at the beginning of this month, that is December, there was another new dinosaur that would be a kind of a prime candidate for, like, quote unquote, best dinosaur of the year in terms of just how interesting it is. But other than that one, which maybe I'll talk about next time we do a news episode, maybe not, we'll see. Um, I think this dinosaur that we're going to talk about in this episode is one of the most bizarre and unexpected new finds of the year, in terms of new species at least. And so this dinosaur is called Berthasaura. And it is a member of a group called the ceratosaurs. Now, the ceratosaurs are one of the theropod dinosaurs, so they are basically the meat-eating group of dinosaurs, even though not all theropods are carnivorous, as we shall see. Um, and it was discovered in rocks that date to the Cretaceous. Now, I say early Cretaceous on here because that's what is written in the paper. However, from what I know, there actually is a little bit of dispute about how old these rocks are, so the dating is not pinned down very confidently yet. It is possible that they are a bit younger than they are mentioned to be here. They might extend into the late Cretaceous instead. Of being early Cretaceous, but either way, they probably date to the Cretaceous, and they are found in Brazil. So this is certainly in keeping with what we know about ceratosaurs, because ceratosaurs are known to have been very diverse in the southern hemisphere continents. So many of them have been found in South America, as this one has been. And if you want some examples of ceratosaurs that you might be familiar with if you are moderately into dinosaurs, there is, of course, Ceratosaurus itself. Ceratosaurus is from the late Jurassic of North America, and I think it might also be known from Africa as well. So that's a pretty well known one. It is known for having like various crests on its head. So it has like two crests above its eyes and then one on its nose, giving it a pretty distinctive look. A lot of ceratosaurs have all these like interesting little ornamentations, ornaments on the top of their skull, and so many of them can be kind of identified in that way. And Ceratosaurus certainly has a pretty distinctive set of ornaments on its head, and it was a pretty large predator, but not the biggest predator in its ecosystem. So it lived alongside things like Allosaurus and Torvosaurus, which are other types of theropods that were not ceratosaurs and could grow bigger than it, at least as far as we know. But yeah, it's a pretty interesting one and a pretty well known one from pretty complete specimens. And another pretty well known ceratosaur would be Carnotaurus, which is from the late Cretaceous of South America, and Carnotaurus actually has had a number of pop culture appearances. Interesting enough, and quite notable ones. Like it was the main antagonist of Disney's Dinosaur, for example. And as you can see, if you remember what it looks like, it also has like these little horns like above its eyes and kind of rather somewhat short kind of snout, so a very distinctive looking head. And yeah, Carnotaurus is also a pretty well known ceratosaur, and it is only known from I think one specimen, but it's a like nearly complete skeleton, so like pretty much most of its anatomy is pretty well understood, and it also kind of has been known for the large muscles that seem to have been attached to its tail, and so these particular muscles in dinosaurs, and in fact in most other reptiles, are the muscles for like pulling the hind leg backwards. And of course, theropods are all like two-legged animals, and so these would be their kind of main muscles used in locomotion. And so these very large kind of muscles on the tail of Carnotaurus, which we can tell the size of based on like the shape of the tail vertebrae, seem to suggest that it probably was a pretty fast animal. So it might have been able to kind of sprint after prey, which is pretty impressive for a large animal. It is quite a large theropod, like not one of the biggest, but pretty big, like in the range of like 8 meters long or something like that. So something like rhino sized in terms of body mass. Yeah, so one of the top predators probably in its ecosystem. But in any case, this new dinosaur, Berthasaura, is definitely very different from both Ceratosaurus and Carnotaurus. First of all, it's much smaller than either of them. So the specimen that we have is only known from one specimen, but that one specimen is a nearly complete skeleton. And so we also have most of the skeleton of this animal, and you can see that in the diagram shown here. the bones in white are the bones that we have from the specimen, and so you can see that nearly the entire body is like represented. And so it is much smaller than Carnotaurus and Ceratosaurus. In fact, it is less than a meter long. So yeah, very small dinosaur. And it is thought that it probably was not fully grown, that this particular individual, when it died. However, it was probably also not like a very, very young baby either. Like it wasn't just hatched out of the egg or anything. So it was probably like approaching adulthood. So like the equivalent of a teenager, perhaps. And so it probably wasn't going to get a whole lot bigger than it was already. So this was, at least it seems to have been, genuinely small dinosaur even as an adult. And probably the most unusual feature that it has is its skull. Now, its skull, which you might be able to make out from the figure here, is kind of short and deep. And the thing that you might not be able to see too clearly here, actually, will show a figure showing the skull in a clearer view on the next slide. But maybe if you squint, you can make it out here. Is that it was toothless. It didn't have any teeth at all, which is very strange for a ceratosaur because most other ceratosaurs were large predatory animals. Well, some of the other ones were pretty small too, but okay, most other ceratosaurs were carnivorous, as far as we know. Like they had mouthfuls of sharp teeth for catching prey and processing flesh and all that. But Berthasaura definitely was not one of those. It's got like absolutely no teeth at all. So yeah, very strange. And so, as far as we can tell, probably these toothless jaws were covered in a beak, which is typical of reptiles that lose their teeth. And most likely it wasn't eating much meat, if at all. Certainly it wasn't like going after any animals that were similar in size to itself. Probably it was eating plants, or maybe occasionally animals that were small enough to like easily fit in its mouth, like insects or things like that. And so certainly that is very strange for this group of dinosaurs. But interestingly, it is actually not the first example of a toothless ceratosaur. So we actually did have another one known before, and that was Lemusaurus from the late Jurassic of China. And Lemusaurus is another one that's known from many excellent skeletons. Yeah, actually, yeah, Lemusaurus is known from like not just one individual, but many. And so we have a pretty good idea of its anatomy. And yeah, it was another toothless ceratosaur. Now, its skull shape was a little different from that of Berthasaura. It kind of had a longer and a narrower snout than Berthasaura does. But it was another example of a toothless ceratosaur. And something else very interesting about Lemusaurus is that because we have multiple specimens of different ages, like different growth stages, we know something strange about its kind of ecology and its anatomy as it grew older. And that's the fact that juvenile Lemusaurus had sharp teeth, whereas the adults did not, and instead had a toothless beak instead. So what's up with that? And it turns out that probably what was happening was that the juveniles of Lemusaurus were meat eaters, or at least omnivores, that were sometimes eating other animals, whereas as they grew older and became adults, the adults seemed to have been more dedicated herbivorous animals that kind of lost their teeth, and they kind of switched to using gizzard stones to process their food. They are often preserved with these gizzard stones in their body cavities. So yeah, very unusual. And we do not have more than one individual Berthasaura, so we do not know if Berthasaura went through a similar process where it lost its teeth as it grew older. That being said, the authors think that this individual Berthasaura represents a growth stage that's essentially equivalent to a stage in Lemusaurus that would still have teeth. So they argue that it is more likely that perhaps Berthasaura either was toothless throughout its life, or it lost its teeth earlier than Lemusaurus did in terms of like when it lost its teeth as it grew up. So yeah, those are some notable differences between the two. And furthermore, the phylogenetic analysis, studying the kind of interrelationships, the relatedness of the ceratosaurs that the authors conducted, did not find Berthasaura and Lemusaurus as each other's closest relatives. Now, if they were especially close relatives, we might think that, oh, okay, so there was this one strange lineage of ceratosaurs that lost their teeth, and then it gave rise to Lemusaurus in the late Jurassic of China and Berthasaura in the Cretaceous of Brazil. However, since these two species were found like very, somewhat, widely separated in ceratosaur phylogeny, at least in the author's analysis, that seems to suggest that there were at least two different times ceratosaurs lost their teeth and gave rise to these bizarre non-meat eating forms. So yeah, quite a surprising find. I was definitely very surprised to see this show up in my news feeds when it came out. It's just an amazing dinosaur, and it's an amazing specimen too. And on the next slide, I actually show you a figure of the skull, just the skull, and you can see kind of accompanied by the different parts, different bones that make up the skull that have been found for this dinosaur. In white, again, are the bones that have been found. And the thing about a Berthasaura, or at least this particular specimen, is that even though it's a basically complete skeleton, the bones are kind of found disassociated, so they're not connected to each other as preserved. So it's if you look at the actual specimen, it just looks like a pile of bones and scattered in a little kind of scattered around each other. And so basically, what the authors had to do is kind of figure out, okay, which bone is what part of the body it belongs to, and then kind of try to piece them together to kind of figure out what the actual shape of this dinosaur was like. And so this is what they came up with. Yeah, it's a very strange looking skull. It's a I don't know, almost turtle-like, I guess. It is very strange. It is, and it is quite different from the longer snout of Lemusaurus. So yeah, definitely a very distinctive new dinosaur, and yeah, I'm happy to see it published. Well, well, what do you think?
Oh, I think it's incredible. I mean, it's one of those things where, growing up learning about dinosaurs, and you're introduced to the theropods, you kind of have this image in your head initially, like, oh, these are the meat-eating
Yep.
dinosaurs, and they all kind of look like Allosaurus or Deinonychus or what have you. But then growing up, as all these new discoveries have been coming in, you learn like, oh, there's a lot of like weird experiments that are going on with this group,
Mm-hmm.
and kind of seeing a weird theropod within the ceratosaur group is like, on one hand, like it's really exciting,
Yeah.
but at the same time, it's like, huh, that's another one to add to the list because um, there are a lot of very aberrant theropods out
Mm-hmm.
there
Yep.
that don't match the sort of moniker of, oh, the meat-eating dinosaur, right? I mean, what comes to my mind is something like Therizinosaurus
Oh yeah.
and that whole group,
Yep.
where like these big pot-bellied panda-looking things with Edward Scissorhands, and they like they're not toothless, but they
Right.
have like a beak in front of the teeth
Yep.
and this big long neck. It's oh my gosh, it's like a chimera almost. It's like
Yeah.
it's just a bizarre animal, and then it makes you curious, like, okay, well, how is this thing living? Like what was its ecology like? And
Right.
I mean, you eventually learn like, wow, the sheer diversity of body forms in theropoda is just far beyond. Oh, this is the meat-eating dinosaurs.
Right.
It's almost like you have to appreciate them for their own sake.
Oh yeah.
Um, yeah, Berthasaura. Wow. You said it was like not a fully grown adult, but
Yeah.
like kind of on that way, like a teenager at most.
Mm-hmm.
It definitely looks almost like paedomorphic.
Yeah.
Like
Right.
that head is huge compared to that body, I
Right.
feel, and it's like it looks like it just hatched out of an egg.
Yeah. Right. Yeah. It does kind of look like that. That's a good point. So yeah, I do wonder if it kind of this kind of body form evolved through some form of pedomorphosis. That's a good question. I think we probably need many more growth stages of different types of ceratosaurs, hopefully including Berthasaura itself. to be able to figure that out. But yeah, I definitely could see that being the case. Um, yeah, I guess something else I'll kind of point out on the skeleton on the first slide is that you can see that the forelimb of Berthasaura is very slender and feeble looking, and now that is not a particular feature that's unique to Berthasaura. It is actually a very common feature among ceratosaurs. So something like a Carnotaurus, for example, has these dinky tiny arms that look basically useless. And yeah, if you think that T-Rex had short arms. Like no, like Ceratosaurus had like way more like useless looking arms than T-Rex did. Um, and yeah, what were they used for? The thing is, we don't know. Like there really doesn't seem to be any kind of obvious function that such weak-looking arms and could really be used for. However, people have found that like the there is still like mobility in some of the joints of the forelimb in these ceratosaurs. Like Carnotaurus is the one I believe that has been specifically studied that it could basically wiggle its arms up and down at the shoulder, and it's like what could that be good for? And it seems like some people have speculated like we can't really test this directly or anything, but some people have speculated that maybe Ceratosaurus might have still like retained these tiny arms for display, and so people have kind of drawn some speculative paleo art of like Ceratosaurs with like skin flaps or filaments or like other showy structures on the forelimbs, and they could kind of wag the forelimbs up and down in some sort of social display, which certainly is possible, and it is difficult to imagine what else they could have been used for. But yeah, definitely one of the other mysteries about the biology of these dinosaurs, and it has also been suggested that, well, maybe given a few more million years, and maybe some ceratosaurs would have lost their forelimbs entirely. And yeah, I mean that maybe that's not out of the question. That is certainly a potential spec evo concept that could be explored. So yeah, that's just something kind of interesting to point out, even though it's not unique to Berthasaura. And yeah, additionally, you are correct that quite a lot of other theropods kind of really deviate from the traditional vision of what like a theropod is. And Berthasaura is certainly not the only like herbivorous theropod that has kind of evolved away from eating meat. Like not only Berthasaura and Lemusaurus, but also, like you mentioned, the Therizinosaurs also seem to have been largely herbivorous. Many of the other groups to which Therizinosaurs belong, or rather, many of the other members of the group Maniraptoriformes, to which Therizinosaurs belong, seem to have evolved away from a mostly carnivorous lifestyle and started kind of doing other things ecologically. So that's where you also get things like the ornithomimosaurs, which also seem to have been like at least non-large prey-eating species. You get things like oviraptorosaurs, which similar story there. Also another group that has evolved toothlessness. Both ornithomimosaurs and oviraptorosaurs have members that are toothless. And of course, Maniraptoriformes is also a group that includes birds, and birds are like wildly diverse in their ecologies, and there are certainly not just non-meat eating forms, but also certain plant eating specialists among the birds too. Like some of the members of the duck and goose group, for example, are primarily plant eating animals. There is the very strange Hoatzin of South America that is a leaf eating bird, and so yeah, theropods have definitely gone into explored these alternative niches many separate times, and it is actually a subject that I'm very interested in. I think my favorite theropods are the ones that have stopped being like a typical theropod and just gone and done other weird things. So yeah, of course I like the birds, and I like alvarsaurs, which are a group of seemingly like insect eating specialists. And so yeah, I had certainly a strange new theropod that is not that does not have a typical meat eating ecology that really catches my eye. So yeah, do you have anything else to add to this?
I think all I'll say is, and you bring up some very good points. I'm glad you mentioned the paleo art that kind of helps emphasize the weirdness of these
Mm-hmm.
animals and kind of highlight it a bit. because I have seen some artists, mostly working for like toy companies
Yeah.
or what have you, where they try to downplay
Right.
the weirdness of some of these animals.
Yep.
Like going back to Therizinosaurus, I've seen some toys where they just make it look like a long neck velociraptor of like Jurassic Park with big claws. And it's like that's not what that animal looked like at all. Like
Right. Right.
it's already like it's it looks cool because it's weird. Why are you like doing it like that? You know,
Yeah.
it just that's always kind of bugged me.
Definitely. I agree. And in fact, not to bring the subject up, but people were talking about this in relation to some of the designs from Jurassic World. Um, like, for example, their
Mm.
baryonyx. It basically de-emphasizes all the things that are actually weird and distinctive and cool looking about baryonyx. Um, so it's I know. It is kind of disappointing when people don't really, when depictions of dinosaurs don't really embrace like what makes them actually real and distinctive. And actually, I would extend that to like not just dinosaurs, but all kinds of animals as well. I feel like I guess I'm going on a tangent here, but like when people use a certain animal in a film or something, like even if it's not an important part of the film, like they're just showing it as like a random focus of a camera shot or like a minor character or something. I feel like it does you good to emphasize how weird those animals are and not downplay them because not just spreading awareness of the animals themselves, but also they can really add to like the memorable how memorable your story is or your work is. So I feel like people should embrace that more when they decide to use kind of unusual animals in their works. But that's neither here nor there. I think should we move on to your first story?
Sure, of course we can.
Alrighty.
And of course we're going to talk about a horse. Um, well, horses and friends. Um, so yeah, the this is kind of a fun one.
Mhm.
The study of stone artifacts, and that includes so-called stone tools. That's like one of the hallmarks of paleoanthropology. If you're interested in the field, well, you'll be familiar with the images of like the Acheulean hand axes,
Mhm.
or like an image of a Neanderthal, using knapped stones to prepare a hide or something like that. One of the issues surrounding the study of stone artifacts is determining if said finds were actually produced by hominins in the first place.
Mhm.
And this becomes more difficult the further back time you go. So, for example, there have been several reported finds in Africa surrounding the Oldowan industry or Oldowan toolkit. If you remember from Humanity a Prologue, we
Mhm.
talked about this, which were used mostly by members of early Homo. So things like Homo habilis. Of course, we now know that Homo ergaster was making these too, at least towards the tail end of its use. And then, of course, we have even older industries like the Lomequian, which is recently discovered, probably made by the hands of Australopithecines. And some of these discoveries, they can be fairly linked with hominin activities, and determined to have been produced by hominins by using a strict series of criteria that an archaeologist can use when they're examining tools themselves. And so, particularly, and I'm going to here quote our featured article, they're looking for conchoidal fractures, controlled hammerstone impact on cores, and repeated and often sequential removal of flakes from cores. So, the last part, for example, like you can take the pieces of some stone artifacts and you can put them together and you can determine like at which point certain flakes came off. Like, yeah, that's a thing you can actually do. It's really cool. Um, and what's important about that is, you don't see those sorts of marks by natural processes, something like erosion. But in other cases, however, things can be tricky. So we have since learned that capuchin monkeys can also produce stone artifacts. Specifically, they will hit two rocks together in order to break them apart. And it seems like they're possibly doing this so they can get at the stores of silicon, within the rocks, which they then lick off for nutrients. It's kind of like getting your vitamins. Now, while this is not the same process as stone napping per se that
Hmm.
we see in hominin sites, it has been argued that these monkeys produce similar artifacts that could be confused for flakes and hammerstones. Now, admittedly, this is kind of an isolated example
Hmm.
among the non-human primates in the wild. I know there have been work on captive chimpanzees and bonobos where they have used stone tools, but we have yet to find that in the wild per se. But it does raise some caution whenever we find evidence of stone artifacts without any accompanying remains of hominins, because they could very well have been made by a non-hominin animal of
Hmm.
some sort. And so this paper by Santiago David Dominguez Solera and colleagues adds a further, probably more grandiose wrench into this issue, because they have provided very good evidence that members of Equidae, so that's the horses, the donkeys, and the zebras, well, they can also produce stone artifacts. So, yeah, a horse's hooves, are basically the same as our fingernails. Ergo, they're constantly growing. And so, to prevent overgrowth, just like we do, they have to trim them. And we've known that horses do this self-trimming on hard surfaces for quite a while. But the lead author, Dominguez Solera, made note of some donkeys that he had observed trimming their hooves on rocks and causing them to break. And so when he asked the owners of the animals about this behavior, they had said, "Oh, this is just a regular thing that they did."
Hmm.
And given the breakage of the rocks, gave a very particular resemblance to Oldowan stone tools, they decided to make some scientific observations of this process, to see whether the resemblances were enough to make a suspicion that both horses and hominins could make artifacts similar enough that they could be mistaken for each other.
Hmm.
And so to do this, they went to a farm in Cuenca, Spain, and looked at 3 adult donkeys, which you can see in the image here,
Hmm.
as well as an adult horse, a mare. Now, they lived in this wide open space that had all kinds of sandstone and limestone rocks, which were already broken by the donkey's hooves. And so, to kind of test this, they added some fresh quartzite and some flint cobbles that had not been altered previously. And that's important because, those happen to be particular rocks that were often used by hominins who made the Oldowan industry. So they gave these equids 52 days to use the rocks, and they had to rely on the farmers' observations as well as camera footage, which confirmed their use. And the same image here, you can see the donkeys kind of going to town on these rocks. Um, and yeah, they caught what they were looking for.
Hmm.
So donkeys and the horse, they would stamp their feet onto the rocks and kind of press their hooves into the stones to trim them, which would produce breakage due to the force. And afterward, the remains were mapped and they were examined very closely. And then they also did some additional observations of the animals after the fact, just to kind of make sure that this was not a once-off. Um, but no, they definitely got what they were looking for. So the actions of these equids produced about 37 stone flakes and cobbles, including some that are photographed here, which the authors were able to refit together to give a chronology of their breaking. Again, this is a tradition when studying hominin stone tools, if you happen to be lucky enough to find all the pieces in the
Hmm.
first place. And so the team then compared these remains to those from several African Oldowan sites, as well as, to these Capuchin sites. And they plugged them all into what's known as a hierarchical cluster analysis, which is kind of similar to a cladogram,
Hmm.
where you use a program to group alike objects together based on the degree of similarities based on your measurements. And what they found was that the equid produced artifacts and the hominin produced artifacts matched up fairly well in that the methods of napping were close. And this is despite the fact that that one method involved stamping a hoof into the ground, and the other involved primate hands striking a core stone, lying on a stone anvil with a hammerstone. And so the method used by the donkeys and the horse, granted, were found to be a lot less controlled than the Capuchins,
Mm-hmm.
because the latter were intentionally trying to break the rocks, while the former, they're just trying to sharpen their hooves. The breaking for them, is inconsequential.
Mm-hmm.
Regardless, the authors noted that some of the flaked cobblestones made by the horses were indistinguishable from those made by hominins.
Wow.
And the hierarchical cluster analysis actually placed the equid artifacts, and I love this. They actually dubbed this the donkey flake assemblage. So you give a formal name to this. Um, but like those were closest to these East African Oldowan industries. And so I think the significance of this study, and the authors certainly think so, it's pretty big. I do think the concerns regarding archaeologists mistaking, Capuchin stone tools for hominin stone tools, that might be a bit overblown. I mean, Capuchins have such a specific range that it doesn't really factor into hominin archaeology,
Mm-hmm.
at least in, Afro-Eurasia. But, horses and their relatives, they've been found all over the world, in the Americas, where they first evolved, in Eurasia and in Africa, and in many cases closely associated with hominins. They're sharing the same ecosystem. So, while we lack observational evidence of equids doing the sort of self-trimming with rocks in the wild, it still stands to reason that there is a much more likely chance of mistaking their flake debris with intentionally produced hominin artifacts.
Mm-hmm.
And this is particularly concerning the old one and earlier industries of which we're concerned, because a lot of these are very controversial. Even the Lomequian is a bit controversial. You still have some paleoanthropologists who are hesitant to agree
Mm-hmm.
that those particular artifacts are a hominin stone tool assemblage in the first place. And so the authors, quote, say that the relevance of this discovery with captive equids lies not only in that it proves that stone artifact making is not unique to the hominin lineage or to capuchin monkeys, but that now archaeologists will be compelled to determine what features differentiate flake and cores made by early hominins from those byproducts generated by other primates and equids. And that could make all the difference in determining if a newly discovered stone assemblage, for example, if they find one even older than the Lomequian, you know, represents crucial evidence of early hominins making tools, or if it's just, horses getting a manicure. And so, yeah, that's sort of the situation that we're in right now. Yeah, what do you think about all this, Albert?
Wow. Like, yeah, this is a really interesting study. That's for sure. Um, and yeah, definitely, I definitely think that they've made a pretty good case that this should be something that people should consider when they're interpreting what they think are hominin created stone artifacts. And wow, yeah, though I like when I first saw this, it was it started out kind of funny because I think people were talking about it like, oh look, horses can make stone tools or something like that, and I'm like, what is that? What did you say? Of course, clicking into the paper and then actually kind of. Oh, well, I didn't read it in much detail, but skimmed enough to get the gist, and it's like, oh yeah, no, like that is a quite an interesting behavior, and does seem to be a plausible way that you would see kind of these stone tool looking artifacts getting made, and yeah, I definitely do hope that it is taken into account in future research. One thing I'll add, I guess, is that another animal for which at least the potential to create kind of stone artifacts in the rock record has been considered is the sea otter, and now, I don't know if it's particularly well studied or not, or like if anyone has actually identified any like ancient sea otter tools from the rock record. but I do know it has been discussed in the scientific literature, and for quite reasonable reasons, I think, because sea otters, of course, also use stones as actual tools, and what they do is that they will use stones to smash open the shells, the hard shells of the prey that they feed on. So, things like mussels, other kinds of clams, or like things like crabs and such. They kind of break them open using stones, and it is reasonable to suppose that perhaps some of these stones could be identified based on like the wear that they undergo as they're being used in this way, and make their way into the rock record, and thus we could have like a stone age of sea otters, or something like that. So yeah, no, I think it is definitely worth studying and also acknowledging these instances of kind of non-human animals creating very similar structures to what we might expect to see in our own lineage instead. Um, that is a Yeah, no, that is a fascinating subject, definitely.
Yeah, I'm glad you think so. I know definitely I can see some implications of this already,
Hmm.
and I should probably state for the record again that the stone artifacts here that we're concerned about, mixing up with hominins or horses, regards things like the Oldowan and
Yeah,
earlier
right.
industries. That's not to say that like we find like an Acheulean hand axe or like a
Right.
Mousterian tool, and then it's like, oh, a horse made this.
Right.
Like this these are very I don't want to use this word, but it's a very simple method of stone tool making that
Right.
we're dealing with, rather than some of the newer ones that have existed. So like I know there's been a lot of discourse about early peoples in the Americas, and how a lot of these early archaeological sites that are predating some of the more conventionally accepted dates include stone tools.
Hmm. Right.
Um, but the thing is, like, those particular tools are not like Oldowan tools. Like they match more what we see um, with like later Acheulean toolkits, for example, or the Mousterian. Um, so I don't think like it would be a stretch to say, oh, we're finding these supposed tool sites in the Americas, uh, but oh, horses can make stone tools. I mean, oh, horses are in the Americas. Therefore, maybe a lot of these stone toolkits are probably made by horses. I think in those instances, it's like I think the good case can be made that that's not
Right.
what we're looking at. Like the signs of human use by these tools are a lot stronger than a horse stamping at it with its hoof.
Right.
Um, because, like for example, like the older one is well known in Africa, but we do see Oldowan tools across Eurasia, especially in more recent finds. Like we've talked about some of those 2 million-year-old sites in East Asia, for example, that have been argued to be, oh, here are hominins that lived much earlier in time than Homo erectus hanging out in Eurasia. But we don't find their bones, but we find their tools, so they might be there. I think that's a little bit more of a relevant situation to look at. So like, are these East Asian stone tools, made by these earlier groups of hominins who have left Africa and have expanded their population into Eurasia, or are these just horses having a spa day? And like I would like to know for sure, because those particular sites are very very crucial for talking about the environmental capabilities of earlier hominins, and whether they were restricted in their ecology, or whether they were a little bit more plastic like later hominins, where like something like Homo habilis stuck living in a sort of like open woodland savanna environment until we get other species who evolve and they have a little bit more flexibility, and eventually you get things like Homo sapiens, who are the generalist specialists. They can go anywhere. Those are important questions
Yeah,
that,
totally.
I would like to know. But of course, it won't mean anything unless we can be sure, absolutely sure, that those toolkits that we're finding, were actually made by hominins in the
Hmm.
first place.
Yep.
So yeah, definitely curious about that for sure. But if you don't have anything else to add, we can go on to your second story.
Yeah, sounds good to me. Um, Okay, so interesting enough. My second story is also about a toothless Mesozoic reptile, but it is one that is, in some ways, quite different from Berthasaura. So this is a reptile called Effigia. It's not a new species that was, just recently named. It was named in the mid 2000s or so, and it is much older than Berthasaura. So it comes from the late Triassic, so over 200 million years ago. So that would be at least 100 million years older than Berthasaura. And furthermore, it it was not a dinosaur. In fact, it was a stem crocodilian. So that means its closest living relatives are the crocodiles and alligators. But it is definitely not a member of like the modern group of crocodiles and alligators. So it's kind of along the stem leading up to them as a kind of weird cousin. Um, and it was found in New Mexico, so it's from North America. But what's especially notable and weird about Effigia is that even though it was a stem crocodilian, it looked very, very, very different from what you would imagine a crocodilian to look like. So it was bipedal; it ran around on two legs, and furthermore, as I just mentioned, it was toothless. It didn't have any teeth at all. Um, so yeah, yeah, very very unlike kind of what you would imagine a crocodilian to be like. And again, it's not a true crocodilian, so it's a kind of a weird earlier branch. But in any case, you still probably would not expect like the crocodilians to be its closest living relatives if you just saw it at a glance. Um, and so yeah, we have this. It's rather small. It's about 2 meters long, um, and so we have this kind of smallish reptile running around on two legs. It's got a relatively small toothless head on a somewhat long neck, and so it has generally been considered something that is a convergent. It converges in form on the uh, ornithomimosaurs. So these are, as I mentioned earlier, another group of kind of non-flesh eating theropods. Um, and also with modern ostriches. So, of course, ostriches are these, two-legged reptiles. Yeah, birds are reptiles. Two-legged reptiles that run around and have a small head on a long neck and a toothless beak, which they use mostly for plucking plants from the ground. Um, and so, yeah, we have this stem crocodilian that looks like sort of like an ostrich or an ornithomimid. And also, I might also add that Lemusaurus, that weird ceratosaur from late Jurassic of China that I mentioned earlier, it also has a kind of rather similar form to these groups as well. So all these different, very distantly related groups. So we have a stem crocodilian, Effigia. We have a ceratosaur, Lemusaurus. We have ornithomimids, which are theropods that are somewhat closely related to birds, but not super close. And of course, we have ostriches, which are birds themselves. All of these groups kind of all converge towards a similar body plan, even though they're not like especially closely related to each other. But until now, we did not really have any kind of detailed study on exactly what Effigia was doing. Like, in general, people just looked at its overall anatomy and said, well, it looks generally like an ostrich or these ostrich-like creatures. So presumably, it was behaving somewhat like an ostrich, like running away from predators and perhaps using its beak to grab plants and such. Plant-eating bipedal toothless stem crocodilian, which is very weird, but at least we have a sort of modern analog for something for how it might have behaved. So this new study decided to kind of test this idea in more detail, and what they did was they specifically focused on like the cranial biomechanics, so how the skull worked in this animal. And so what they did was, since Effigia is known from a pretty complete skull, They first reconstructed the skull in kind of its original, with the original kind of positions of the bones and such, because even though it is rather complete, I believe the material is still a little bit crushed and scattered. So they needed to kind of reconstruct the original shape of the skull, which they did by kind of scanning the elements and reconstructing it in a computer. And then they also reconstructed where the jaw muscles were likely to be and how big they were, which can be inferred by studying like living crocodilians as well as birds, because both birds and crocodilians are archosaurs. They are like each other's closest living relatives, even though they don't really look very similar now. And so knowing, what the shared kind of features of the jaw muscles in birds and in crocodilians can help us reconstruct the jaw muscles of extinct archosaurs, like the non-bird dinosaurs, or in this case, the stem crocodilian. And finally, what they did was they used a method called finite element analysis on the reconstructed skull of Effigia. And finite element analysis is a method that kind of originated in engineering, and it's usually used to test like the structural strength of things like buildings or vehicles. And what it does is it divides up complex shapes into like individual elements. That's why it's called finite element analysis. So they kind of divide up complex shapes into these simpler elements, and then you can then like kind of specify the properties of what these elements are made of. In this case, they're made of bone, but you can also specify they're made of concrete or whatever. And then given those material properties, you can build up like these complex shapes that you want to test, and then the analysis will use the material properties that are input into the analysis to study how the structure is going to react to different types of forces or different amounts of forces applied to it. And that's what they did. And this is a very common type of method that's often used nowadays to study the biomechanics of extinct and living animals. And that is kind of what is pictured on this slide here, in fact. So this is a figure showing some of the skulls that they tested. So the top two, A and B, are skulls of Effigia. And they tested kind of two alternatives for the size of the beak in Effigia. So, because Effigia was toothless, was a toothless reptile, we're fairly confident that it had a beak covering its jaws. But what we don't really know is exactly how large that beak was, like how much of the jaws was covered by the beak. So they kind of tested two different possibilities. So you can see in A, the had a beak region, the blue part at the tip. The front is towards the left, by the way, is smaller, whereas in figure B, the beak is larger. In the middle, C and D, that's the skull of an ornithomimosaur. And ornithomimosaurs also probably had beaks, or at least the toothless ones did, which this one is. And we also aren't sure about the exact size of the beak, so they also tested two different possibilities here. So there's a version which is labeled C, which is a smaller beak, and letter D is a larger beak. And finally, we have two kind of living archosaurs to compare to these extinct ones. So on the bottom left, letter E is an ostrich skull. And of course, we know how big the beak is in an ostrich, so we don't have to do alternative kind of testing there. And letter F is an alligator, so kind of one of the closest living relatives to Effigia for comparison. And so they tested kind of different scenarios in which the jaws might have been used. So like biting something at different points in the jaw, for example. In the particular figure shown here, what it's showing is that it's showing the what would happen if the skull was being used for pecking something. So like the skull is being thrust forward, and the tip of the snout is like contacting whatever is being pecked. And so you can see that there's this little red arrow on each of these skulls here, and that's showing kind of where the force is being applied in this kind of simulation. So in a pecking kind of simulation, of course, the force is being applied to the tip of the beak. And then the different colors being shown on the skulls here, that's kind of showing how much stress is being experienced by those parts of the skull during this activity. And so warmer colors, like the red, being shown here, and the greens and the yellows towards basically towards a warmer end of the spectrum. Those are higher stresses, as indicated here, whereas the blues are lower stresses. What you might see pretty clearly here is that during this pecking simulation, there's a lot of kind of high stress going on in the skull of Effigia, and also in the ornithomimid too, for that matter. Whereas the ostrich, most of the skull stays blue, which makes sense because we know that pecking is a behavior that ostriches often use to procure their food, and so it probably wouldn't do them very good if that their skull was not very well built for pecking. Now you do see a region like kind of above the nose of the ostrich here, like kind of midway up the beak, where you do see like a region of high stress. However, the authors point out that this is probably like an artifact that does not actually reflect the true kind of stress distribution in an actual ostrich skull. And the reason for that is because they did not model what they call the sutures. So kind of the skull was composed of a lot of different individual bones, and kind of the connections between those bones are called sutures, basically. Kind of the spaces. There are like the spaces that join them together. They did not model the sutures in this model here, and we know that sutures can be very important for kind of dissipating stress in a lot of cases, and so probably an actual ostrich skull with the sutures would not experience such high stresses in that region of the skull. But in any case, the important takeaway here is that the ostrich skull is actually behaving very differently in this simulation from Effigia or from the ornithomimids. And that suggests that even though Effigia and ornithomimids are superficially very ostrich-like, they probably did not feed by pecking like ostriches do. So probably they were feeding in some kind of different manner. And of course, the alligator skull is behaving pretty differently from all the others in this that they studied in this simulation. For one thing, alligators do not peck their food, so this is clearly not a common kind of force that they would encounter, and so of course the alligator skull is not especially well built for pecking, and of course the shape of the skull itself in an alligator is not very similar to any of the others, and so it is behaving quite differently as one would expect. If Effigia and ornithomimids, for that matter, were not feeding by pecking, what were they doing? When it comes to the results that the authors got from simulating biting behavior in Effigia, the authors found that in general, Effigia experienced pretty high stresses, like above its nose and also in its lower jaw. The lower jaw isn't shown in the figure here, while it was biting. And so they suggest that probably it fed on mostly relatively soft plants and wasn't like kind of crushing very hard food items or anything with its beak. Now that being said, they do also point out that the beak tissue does mitigate a lot of the stress here, and this has been found in previous studies that having a beak is very useful for kind of reducing the amount of stress that the skull is experiencing, and you can see it very clearly in the kind of pecking simulation here too. Like even though the rest of the skull is experiencing quite high stresses in Effigia and the ornithomimid, you can see that the part of the skull that's covered by the beak is experiencing very low stresses. So the beak is quite important there. And so basically, Effigia probably wasn't eating spectacularly hard types of food items, but it probably did. It probably was able to mitigate some of the stresses that it experienced by having a beak, and just kind of based on like the way that the upper and lower jaws kind of fit together, the author suggests that maybe Effigia was mostly using a cropping kind of motion when it was feeding. So the upper and lower jaws would kind of slide past each other, and of course they would be covered by this beak tissue, and so they would use the beak tissue to kind of slice off parts of plants that it wanted to eat, and not especially hard parts of plants, but you could probably do that pretty efficiently. And cropping, as in general, is not a very kind of stress inducing behavior compared to other kinds of biting. So that does seem pretty plausible for Effigia. Um, on the next slide, the authors, this is a figure from the paper that the authors included, which is a restoration of Effigia doing some feeding behavior. This is by the paleo artist Mark Whitten, a very well-known paleo artist who does some excellent work. And so this is showing what Effigia might have looked like in life and showing the type of feeding behavior it might have engaged in. So it's like feeding on these newly grown in fronds that are growing here, and presumably about to use its beak to kind of crop off some of that vegetation to eat. Something I'll add here is that the Effigia here is clearly kind of rearing up to reach those leaves. And so, no, we don't really think that it would have been standing in this kind of tripodal posture all the time. Probably more commonly, it was kind of more similar to like dinosaurs, where the back is more parallel with the ground when it was running and walking. But of course, animals can get into all kinds of interesting poses when they want to get something done. So quite an interesting restoration of Effigia. It does remind you a bit of like kind of old school dinosaur depictions, which might not be too far off from what Effigia look like. Those things like the ornithomimids nowadays, we know that they would have been covered in feathers, so probably looked a lot more bird-like, or even more bird-like perhaps, than traditionally depicted in like old paleo art. Whereas Effigia being a stem crocodilian, we currently don't have any evidence that stem crocodilians had any kind of like feathering or like feather-like structures on their body, and so you get this kind of bipedal, perhaps mostly scaly animal running around in the late Triassic. And we now know that its cranial biomechanics were not exactly quite like those of an ostrich. Probably it was in some ways kind of doing its own thing, and that's kind of a common trend when you look into these examples that have been given for convergent evolution. It certainly does happen, and I would say that perhaps to some extent we can still consider this to be convergent evolution, this general kind of bipedal, fast-running body form with a toothless head for eating plants. That's something that's still shared between Effigia and ornithomimids and ostriches and presumably also Lemusaurus. But the kind of the devil's in the details, and like the exact ways in which they operated probably should not be assumed to be quite exactly the same. And so that is a really interesting study, I thought, on like a really interesting animal. I'm curious to hear what you think.
Well, first of all, I'll say that I love this reconstruction. I'm not used to a lot of depictions of Effigia.
No.
What's kind of funny to me is like this one looks like Berthasaura.
Right, yes.
Because I don't know, I never pictured the skull
Mm-hmm.
looking like that before.
Right.
This is probably because, oh my god, like a decade ago, Dorling Kendersley, book publishing company. If you've seen like the little logo of like the book opening with the DK,
Right.
you know who I'm talking about.
Oh yeah.
But they had a large visual encyclopedia of prehistoric life that I just devoured all the time. It was a wonderful book. It would profile all these different fossil plants and invertebrates and vertebrates. And of course, there are lots of dinosaurs and other archosaurs in the book. And it had a whole page spread of Effigia, a bunch of them kind of tiptoeing through a swamp. And I guess this is a decade ago.
Right.
Here they were really trying to emphasize like, oh, look how much this looks like a naked ornithomimosaur,
Right.
and like the head looks very like it looks very much like one of those animals. So like to see this restoration, it's like I wouldn't look at that and think Effigia, but
Right.
I
Right.
guess that's what it is. So, because like, do we have like a complete skeleton of this animal?
We have like a nearly complete skeleton, I think. Yeah, like basically most of the anatomy we understand what it looked like pretty well. And yes, I'm glad you pointed that out because you're not the first person that I've heard say like, oh look, Effigia looks a lot like Berthasaura, and it's quite a coincidence that these studies kind of came out on the same during the same month. Yes, and in fact, the authors do point out that. In their kind of skull reconstruction of Effigia, they did find that yeah, the lower jaw is quite deep. So in that sense, it is unlike ostriches or ornithomimids, which have much like narrower lower jaws. Whereas it is indeed kind of more similar to Berthasaura in that regard. Yeah, it would be fun for someone to do a biomechanical study on
Yeah,
Berthasaura. Yeah.
of course. Yeah, I mean, I you know me, I love studies like this
Mm-hmm.
where you get the biomechanics and you really start to dig into, okay, what were these animals like in life? What were they using with their bodies?
Right.
Um, yeah, I guess again with my limited knowledge of Effigia, I never would have expected that it wasn't pecking things around like an ostrich
Mm-hmm.
or an ostrich dinosaur, which is kind of a redundant because ostriches are dinosaurs, but you get the idea.
Right.
Um, um, wow. Okay, so cropping soft plants. You know, I was actually surprised to learn like the role that the beak does in reducing
Mm.
stress. Um, now, is that I don't know if you happen to know, is that like across the board with beak animals? I mean, I know our sample size. I mean, we have like turtles, but
Right.
like, do you know if that's the same for them? Like, because turtles tend to kind of crop their food a bit. Well, I
Mm-hmm.
mean,
Yeah,
they kind of like
definitely.
stick their whole head in there and then just scoop things up.
Yeah, for sure. So I don't know. I don't think it has been like studied directly in like a huge sample of beaked animals yet. Um, but I would expect that it probably is a pretty common function of having a beak. So the study, or at least one of the kind of main studies that kind of showed this function of having a beak, was actually done on therizinosaurs. So as you mentioned earlier, therizinosaurs, even though they do retain teeth, they have a kind of toothless tip of the jaw, which was presumably covered by a beak in life. And it was shown, in fact, by some of the same authors of this paper, that having that beak there probably was helpful for like cropping plants and reducing the stresses that were being induced while doing so. And so, yeah, I do think even though our sample size currently is pretty limited, it probably is a pretty common function for a beak to have. And in fact, I can easily buy that it perhaps was the main function of the beak in many of these beaked groups because we often see beaks arising in a lot of these archosaurs and actually in some other reptiles too, as you mentioned, turtles, of course. That in many cases seem to have been mostly plant eating. And so it seems that having a beak kind of replacing the teeth is something useful that to kind of herbivorous reptiles. And probably it is for this reason that it kind of mitigates the stresses that are induced while doing this kind of and at the same time a beak kind of serves as a kind of continuous cutting surface that is useful for cropping plants. And so yeah, I do think that is very likely to be a very important function of the beak. And I guess while I'm here and mentioning that, um, it is often said, and you'll still see this in textbooks and documentaries and whatnot, that that is commonly thought that birds lost their teeth and gained a beak instead to save weight, basically, and to make themselves lighter so they can fly, and that is
Mm-hmm.
almost certainly not the case. So, for one thing, we actually don't see a trend towards toothlessness in dinosaurs like with the origin of flight. It's not like you start getting flying dinosaurs and then you start getting a trend of all of them starting to lose their teeth. Like no, like a lot of flying dinosaurs from the Mesozoic retained teeth, and it is only it's happenstance that the only living dinosaurs today happen to be toothless. But in the distant past, during the Mesozoic era, there were many different types, many different groups of flying dinosaurs, some of which had teeth, some of which didn't, and some of which only partially lost their teeth in some parts of the jaw but still had teeth in other parts, and so on and so forth. So I think it's much more likely that the beak originated as a feeding adaptation and not to make the body lighter. And another reason we don't think that, or we don't think anymore, that the kind of lightening the body is the main function of the beak, is that basically the teeth of a lot of these early flying dinosaurs does not account for a very big proportion of their body weight. Like people have actually done the calculations and said, yeah, like losing the teeth doesn't really do much to reduce your weight. And in fact, in the study looking at the Therizinosaur beaks that I mentioned earlier, they also actually modeled this possibility. Oh, does having the beak instead of the teeth reduce weight, like in the skull or whatever? And like no, the answer is no. And in fact, having a large beak can actually be heavier than having a mouthful of teeth in the same region. And so, yeah, no, the beak is definitely not a weight saving adaptation. Yeah, definitely, there's definitely something else going on with that, and it seems that certainly in a lot of these non-flying groups, the answer was feeding, and I would imagine that for the flying dinosaurs too, I think probably the main driver was feeding as well. So yeah, do you have anything else to add, or should we continue?
Yeah, I mean it's incredibly fascinating, but we can definitely move on.
I'll just mention one thing before we get there, and it's quite interesting, I think, that not only is there a thematic connection between the two stories I picked, but also that we are gonna we started with a Brazilian fossil from the Cretaceous, and now we are going to end with a Brazilian Cretaceous fossil in your final story.
Yeah, I was actually kind of surprised how that worked so well. Um, but what's also kind of nice is we have a first for through time in clades.
Hmm.
So as you can see on this slide, we are finally going to talk about squamates.
Oh wow.
So, yeah, for those not in the know, the clade squamata basically refers to the lizards,
Hmm.
of which snakes are a part. Yes, snakes are lizards. They are just one of many groups of lizards that have lost their pelvis and limbs over evolutionary time. For example, we have like slow worms, dibamids, amphisbaenians, pygopodids. These are all other examples of legless lizards that are often confused for snakes. But this has happened many times in evolution. Um, these groups include legless members, and I say include because all of these groups do contain members that still have remnants of their earlier four-legged ancestry.
Hmm.
So if you had the chance to see like a boa constrictor or a python up close, like if you own one as a pet, you might have noticed that they have a little pair of spikes on either side of their anal vent. These are their pelvic spurs, and those are all that's left of their hind legs.
Hmm.
They're basically the snake's femurs.
Hmm.
The pelvis itself is actually vestigial. It doesn't even connect to the spine
Yeah.
anymore. It just kind of sits there, floating in the muscle. But yeah, like that's a thing that some snakes have, and why should they still have these? Because clearly they're not walking on these. Um, well, they are used for sexual reproduction. Male snakes tend to have longer spurs than females, and they use these in part to kind of grab onto the female during mating. And I know some species of snakes will like use them in like mating combat too,
Right.
like males fighting for females, which it must be like a hilarious image. But yeah, I mean, I think that's particularly neat. And of course, this is my opportunity to do my duty for the online natural history community and give a shout out to the Squamates
Oh
podcast.
right. Yep.
Um, yeah, which is hosted by Mark D. Schertz, Gabriel Aguido, Hiro Nayak, and Ethan Kosak, who are all wonderful people, and you should go check them out. and their work. The podcast is exactly how it sounds. They talk about all things squamates, lizards, and snakes. And there's often a lot of humor involved, and you get kind of like up to the minute news. Well, at the times of release, of course,
Yeah.
of like what's going on in the world of squamate studies.
Yeah, they also talk about other non-avian reptiles and amphibians as well.
Right. Yeah. So it's like it's like a general herpetology
Yep.
podcast, if you will. But yeah, so we will definitely put a link in the description if you guys are interested in
Yep.
checking that out. So, okay, snakes or lizards, cool. We should all know snakes fairly well. I'm sure many of us live in regions where there are snakes that we sometimes encounter in the wild. I'm certainly, well, I've certainly been in that position before. Of course, having lived near the Dismal Swamp State Park for much of my life, it's very easy to find various snakes, mostly non-venomous forms, thank goodness. So we have three venomous types here, of which like the cottonmouth is one. Um, Albert, I know you're in the UK. I understand you guys have a few snake species there, but
Yeah.
not a whole lot.
No, no. We have a few species over here, but yeah, only a small handful. Yeah, there are like you can count like the number of species of non-avian reptiles on uh, in the UK as on like a couple hands or something like that. Yeah.
Wow. Oh, too funny. But yeah, so like even so, like snakes are so ubiquitous in popular culture.
Yep.
Like you know a snake when you see one, unless of course it happens to be a legless lizard of some form. Which in this case, there's little details there, but that's beside the point. Um, what type of lizard then are they? Where do they go on the great family tree of lizards, of which there are like thousands of species? Well, that's always been very troubling because historically we have had a lack of very good snake fossils that could give us clues. It's really not until like the 2000s when we have fossils like Najash rionegrina from the late Cretaceous of Argentina that have both fairly developed hind limbs and a pelvis that is still attached to the spine. Or, for example, there's a Eupodophis desquensii from the late Cretaceous of Lebanon, which has a similar situation. This has told us at least that at some point in snake evolution, the hind limbs were lost after the forelimbs. But we had yet to find a fossil of an early snake that had all four limbs still, which we'll get to in a moment. Now, for the record, crowned snakes belong to a clade Serpentes, but the larger group, which includes all the stem members, is Ophidia. Now, regarding larger relationships among the lizards, morphological analyses have tended to find snakes as close relatives of monitor lizards or varanids. Both are long-bodied predatory reptiles. But in recent years, this has been challenged to an extent. Molecular studies, and sometimes in combination with anatomical studies, which is always a plus, they have recovered a clade of lizards called Toxicophera, which includes not only snakes and monitor lizards, but also Gila monsters and glass lizards, xenosaurs. There's the clade Iguania, which is a very large group, which includes, of course, iguanas, but also chameleons, agamids, anoles, collared lizards, helmeted lizards. So that group. And then, of course, there are several now extinct groups. Most importantly here are the mosasaurs. These were one of the groups of marine reptiles that lived during the Mesozoic era, the age of dinosaurs, often alongside things like plesiosaurs. Now, of course, if you've seen Jurassic World, that's the big aquatic one that's always jumping out of the water to eat things. That's a mosasaur.
Yep.
And yes, they were true lizards. So like the honest to goodness lizards, probably the only big reptiles during the Mesozoic that you could properly call a lizard and still be accurate.
Right.
And you know what? For a while, they were also thought to be related to monitor lizards. So there had been a lot of argument about the relationship between the snakes, the monitor lizards, and the mosasaurs within Toxicophera. That group itself has actually spurred a lot of controversy over the interpretations of its evolutionary story.
Yep.
as the name and initial research suggested, the common ancestor of this group had some sort of toxic saliva that was used for catching prey. Some people would call that venom, others would not, and still others wouldn't call it toxic at all.
Mm-hmm.
Granted, this is admittedly a bit outside the scope of this discussion, but I mean, Albert, if you happen to have any thoughts on that, I'd love to hear them.
Well, no, not especially. It's not really my field, but it's definitely a debate that I've kind of followed from the sidelines with interest. Yeah, definitely kind of the recent studies clarifying and refining our picture of like lizard evolution and lizard phylogeny have all been really interesting. And yeah, no, I'm definitely interested to see where he goes next.
Oh yeah, absolutely. Yeah, squamates are particularly interesting. I think because they are so diverse
Yeah.
that it's often a little bit overwhelming to approach them in the
Mm-hmm.
first place.
Yeah.
Um, like I think out of the non-avian reptiles, they're the ones that make up like the grand majority of that group.
Oh yeah.
Um, there's oh, like 6 or 7 thousand, no, probably like 8,000 or so like squamates versus like 300 turtles,
Yeah.
and like 25, 26 crocodilians,
Right.
and then the Trotara, which is an aberrant New Zealand critter who
Mm-hmm.
has its own interesting history. But yeah, everybody else is a lizard.
Yeah, yeah.
So
In fact, I think some of the latest species counts actually have um, lizards at over like in the 10,000 range. So it's
wow.
like they are equaling or exceeding species count of birds in that regard. So yeah, like even if you include birds within the reptiles, it's like the squamates would still be like a substantial proportion. That's for sure.
Oh yeah. I think it's just remarkable. And like most like new species news regarding reptiles
Mhm.
is usually like a lizard or a snake
Oh
that they
yeah.
find, which is always fun. It always makes that number grow. Yeah, it's funny. Like I remember growing up reading about lizards, and there weren't a whole lot, but like as they've found more species, and of course the usual, oh, this species is actually two or three,
Right.
that number has just blown up, and it's really one of the more remarkable natural history changes that I've noticed in my lifetime.
Hmm.
But yeah, so back to snakes. Um, so the most recent and extensive work on Toxicophera, um, and in fact, this the tree shown here is comes from the second story that I will be sharing soon. That suggests that snakes are more closely related to mosasaurs than to monitor lizards.
Hmm.
In fact, monitor lizards are probably the most far removed clade within Toxicophera, as is shown here. Um, Although there have been some analyses that group them with the iguanians on their own branch. It typically varies, but basically, snakes aren't as closely related to monitors as we once thought. In fact, there's already even a name for the snake mosasaur group. That's a Pythonomorpha. And so this brings us then to another question. What was the common ancestor of snakes like? And, for decades, this question has centered around two interpretations. One, the earliest snakes were burrowing reptiles, and two, the earliest snakes were aquatic reptiles. And evidence that has been put forward for the former hypothesis rested on some of the fossils that had been found of early hind limb snakes, like Najash, for example. Najash has a skull and vertebrae that are clearly adapted towards a burrowing lifestyle. And of course, some of the earliest diverging clades of snakes, like the adorable tiny blind snakes, which if you look at them at first, they look like worms. That's kind of how small they are.
Hmm.
Um, they're also burrowers. And so this implies that the loss of limbs was due to the continued activities of burrowing over millions of years. Snakes with less developed limbs could tunnel through the soil much easier than those without, which is kind of interesting to think about because there are lots of burrowing animals that have really powerful limbs to move them through the soil. So it's like, why were the lizards so different? Um, but we already see instances of this sort of lifestyle among other typically limbless lizard groups.
Hmm.
Amphisbaenians are burrowing animals too. Now, evidence for the latter hypothesis, that snakes evolved from aquatic reptiles, incidentally also comes from some early fossils. There's an extinct clade of stem snakes, and I'm going to try to get this name right, the Cymoliopidae.
Hmm.
And these guys have been found in marine deposits. Eupodophis is a member of that group. And then, of course, there's the proposed relationship with mosasaurs and their relatives.
Hmm.
That group, to date, have all been known to be aquatic reptiles. So perhaps snakes lost their limbs as they adapted to a marine lifestyle, with the undulation of their bodies easier to do with lesser and lesser developed limbs. Yeah, to date, there has been no consensus on this discourse, at least none that I could find.
Hmm.
Um, at the moment, I don't even know if the pendulum has been swinging more in one direction or the other. Um, of course, my gut reaction to this is that things are probably a little bit more complicated than an either or situation,
Hmm.
especially if we're finding fossil snakes, especially fossil stem snakes that are both burrowing and aquatic in nature. Hell, maybe the first snakes used to burrow underwater. I don't know. uh, I know you don't focus too much on squamates, as you said, but I mean, do you have any thoughts on that particular matter?
Hmm. Well, I would say that my impression is that um, while there are people who kind of hold out on the aquatic model, and it is understandable why such a model was proposed for the reasons that you mentioned. I feel like the burrowing model has been gaining ground recently, and to me, I feel like it makes the most sense. Like even if there were a few stem snake lineages that adapted to aquatic life, it would be consistent with all the other examples of leglessness in squamates if it was an adaptation for burrowing, because that does seem to be the driver in pretty much all the other cases. Whereas we don't really have any kind of clear example of limblessness in squamates as an adaptation to semi-aquatic lifestyles among the other legless groups. And I believe that the kind of the very earliest non-controversial uh, snake fossils that are like clearly closer to snakes than to mosasaurs um, seem to be like terrestrial animals, or at least found in terrestrial deposits. And so, yeah, I get the impression that the burrowing hypothesis is the favored one nowadays, but definitely I'm not sure that the debate is over either.
Got it. Okay. Oh, that's really fascinating. I mean, yeah, like that is a good observation that all the other limbless squamates, all the limbless lizards that we have, they're not, aquatic animals.
Right.
They're either like in the undergrowth or they're burrowing. Um, and it's yeah, I can definitely see that for sure. Because yeah, I mean, snakes losing their limbs because of like an aquatic lifestyle. Admittedly, like it does make a little bit less sense to me
Mm-hmm.
than like snakes losing their limbs for burrowing.
Mm-hmm.
All the examples I'm familiar with of a vertebrate group that lived on land initially and then send some members into the water to do that whole thing.
Right.
None of them really. I mean, like there was some like limb reductions, of course. I
Mm-hmm.
mean, like whales and
Yep.
sirenians,
Yep.
the sea cows, they have their hind limbs only, and they kind of have like what snakes are going through. Like they have like a little pelvis that's stuck in their bodies,
Yeah.
and like their hind limbs are just done. Um, but like in other cases, I'm thinking like otters,
Mm-hmm.
sea turtles, penguins.
Yep. Yep.
Like they still have fully functioning limbs. Granted, they're not like strictly aquatic.
Right.
Like, they can come out on land. But in either case, like nobody's like lost all their limbs altogether
Right.
that I can think of. Like even going into the fossil record, we have like mesosaurs
Mm-hmm.
and ichthyosaurs. Yeah, so It's like, why would snakes be like the one outlier out of all of those,
Mm-hmm.
uh, to evolve an aquatic lifestyle and then like lose all the limbs and then like go and recolonize the land supposedly,
Right.
and, then give forth the great variety of, because like most snakes live on land
Yeah.
anyway.
Right.
I mean, there's sea snakes, but
Mm-hmm.
they're like a handful of
Yeah.
species. And like other snakes can swim, but they're not like dependent on the
Yeah.
water per
Yeah.
se.
Right.
So yeah, that does make a lot of sense. Like it just kind of goes to show that even if the pendulum is swinging, there's always going to be some folks
Oh
that
yeah.
point in either direction for their own reasons.
Mm-hmm.
Um, but okay, there you go. So it seems, I guess, the pendulum is swinging towards the burrowing lifestyle first. Um, so that's kind of fascinating.
Mm-hmm.
And incidentally, it's that is important to note,
Right.
because back in 2015, there was one important fossil that surfaced, which proved to be a very big deal,
Right.
and might have helped play a role in answering the big questions of snake evolution.
Mm-hmm.
And if we go to the next slide,
Yep.
we will see that.
Mm.
Yeah, ignore the title for a moment. um, so the fossil below, this is Tetrapodophis amplectus. This is from, as Albert alluded, this is the early Cretaceous Crato Formation of Brazil.
Mm-hmm.
Now, the initial paper which described these remains was written by David M. Martel, Helmut Schlinger, and Nicholas R. Longrich for the journal Science. So that this was a big deal when this paper came
Mm-hmm.
out.
Yep.
The fossil got such a huge press because this was the first specimen of an early snake where we finally had all four limbs still in place. And yes, according to their particular anatomical description, this was a snake, or at least a stem snake, kind of like Najash. Um, if you can tell in the photo here, now the little star on picture A. So this is a counter slab. So you have the rock has been split open, and the animal's remains have been put on both sides of the slab as a result. On A, you can see a little tiny star there on the bottom of that slide. And if you look across from that on picture B, you can see like, oh, this is where the hind limbs are. And I added a little arrow here on picture B. You can kind of make out that's where the forelimbs are. So right away, like this is very strange for a four-limbed animal if
Mm.
you're not used to squamates, because for all intents and purposes, it looks like a snake with like limbs put on as an afterthought. It's like, oh shit, I forgot the limbs,
Right.
and put that there. It would have looked very bizarre in life for sure. Um, so like that particular paper also brought forth an ecological description. The authors were arguing that Tetrapodophis was a burrower that fed on other animals. As evidenced by these rather enigmatic remains of bones that were preserved in the gut region. Like these seem to have been some sort of land tetrapod. And so, of course, this added favor to the idea that the earliest snakes were burrowers. Now, we can't really go forward here without addressing the significant problems with this specimen.
Yep.
Yeah, so for one, it is privately owned. So Martel and colleagues had to get permission to study the fossil at a German museum, and apparently it was a very tight situation. The owner only wanted, and I quote, qualified researchers to get anywhere near this specimen. In fact, back in 2016, so just a year after the first paper, the Tetrapodophis remains were actually seriously damaged. Uh, I guess they were trying to CT scan the fossil, and something had happened.
Mm.
And there were important bones that were damaged on this specimen. So for a while, access was just denied. Nobody could see this thing until a go-ahead was made, and they were sure that they could save the fossil. And even then, permission, when it was finally granted, it was limited to in-house study. There was no shipping this thing anywhere. You had to go there and look at this fossil, and then do your analysis there.
Yep.
So, hence where we are now. The fact that this fossil is privately owned was more than enough for some researchers to argue that we shouldn't even study it in the first place. Private fossils aren't officially registered with any museum institution usually. And because there are often difficulties with the owners in allowing others to study the specimen, the aspects of repeatability in study, which is science 101,
Mm-hmm.
are just not there. If you can't test the specimen a second, third, or a 22nd time, well, then are you really doing proper science? And so, as far as some researchers are concerned, Tetrapodophis, shouldn't even exist in scientific literature.
Mm-hmm.
And of course, there's the whole thing about private fossil ownership that we could easily get into, but from my experience, that's a whole can of worms, and everybody
Right.
has their kind of opinion on it.
Oh yeah.
You know, it, for some, it's not even necessarily like a bad thing, like on paper,
Mm-hmm.
as long as like there are certain guidelines that are taken. Um, I don't know. I mean, I guess if we want to throw this out there, I kind of feel like depending on the circumstances, or at least most circumstances, a fossil should be made available to the public.
Mm-hmm.
Like if you happen to own them and you happen to have like the right paperwork for that, like I mean, like like where the specimen came from and it's like locality information, like you should be able to make that available for people to study, especially if it's important.
Mm-hmm.
Like if you're the dude who has like the only snake fossil in the world with all four limbs on it, like that's kind of a big deal. You can't just like hide that in your living room or
Mm-hmm.
anywhere. Like that could help answer some pretty important questions.
Mm-hmm.
Um, I mean, those are kind of like my immediate thoughts. I don't know about you, Albert.
Oh well. Yeah, like you said, it's a whole can of worms, and we'd probably be here all day if we went into all the
Mm-hmm.
nuances. But I would say in general, I agree that definitely I think scientifically important specimens, at least, should be accessible to the public trust and for any researchers who want to study them to study them. Um, so yeah, I guess that's my thoughts in one sentence. And but of course you can get into like the little arguments about what counts as scientifically important or things like that. But yeah, no, I think definitely something like this, for example. Um, yeah, I would much prefer to see in like a museum.
Oh, of course, and of course there's the whole aspect about colonization too, that
Mm-hmm.
where you know a lot of fossils have been taken from land without permission
Yep.
from indigenous groups, or like other countries, and they're put on museums on, I guess you say, foreign soil, and they're not accessible to the people from which those fossils originated from. And so I know a big part of repatriation of fossils involves, bringing those fossils back to their countries of origin, um, and making them even more accessible for everyone else. Because of course, like if you happen to be in a country that's very far away from where that fossil was found and taken to, obviously there's accessibility issues. There's a whole lot of travel stuff you have to go through and permissions, and it can be very difficult.
Yep.
If you want to study a fossil from where you live, and so, and of course, like again, it's the whole legacy of colonialism as well. Just people taking things without permission and propping them up there and kind of keeping them there.
Yep.
And it's, yeah, it's a huge problem, and I know anthropology is full of this. And so some of you might be surprised that paleontology is as much a part of this as well.
Mm-hmm.
Like there's been a lot of talk about different fossils that have been taken from places. It's like, yeah, this is very much an issue here as well. um, and I guess, yeah, kind of like leading into this, secondly, and perhaps most importantly, regarding issues with Tetrapodophis, is that we don't actually know just where the fossil was found specifically in the Crato Formation,
Mm-hmm.
because the specimen appears to have been actually collected without a permit and illegally smuggled
Yep.
from Brazil. So, given that under Brazilian law, at least since the 1940s, any fossils that are found become property of the state instead of property by some random ass person.
Mm-hmm.
So that makes Tetrapodophis an ethical and legal nightmare,
Yep.
really. Without the possibility of the specimen being repatriated to Brazil, this is yet another reason some researchers are more than willing to denounce these fossils and erase them from scientific investigation. And of course, fossil smuggling in Brazil or anywhere is not limited to Tetrapodophis. There are certainly many other species that have been illegally removed in this way. And on top of that, uh, it has come into public light that Dave Martell, at least, has not been very fair in taking responsibility for this. Um, so there is another Brazilian law regarding paleontology. Um, is that it's that if you find a specimen in the country, you need to have at least one Brazilian paleontologist on the paper team. Which, to put it bluntly, Dave Martell responded with a big old screw you. I mean, I don't need to read his
No,
actual
no,
comment
no,
here,
no.
but either way, that's very unacceptable. Um, and yeah, I think he's even backpedaling on that a bit, but it's like, yeah, you kind of revealed a lot about yourself in your comments, so you're not
Yeah.
off the hook yet, buddy. Um, oh, I mean, Albert, do you have any thoughts about that particular controversy?
I mean, in this particular case, yeah, I think it's pretty clear cut. I mean, this was an illegally exported specimen, and yeah, certain laws weren't being followed, and yeah, thanks to that, we have this whole big old fiasco. And uh, no, it, yeah, it really is a big mess. And at least I think with this and a few other recent related events, I guess it is good that these issues are getting like more public press and people are being made more aware of these nowadays.
Mm-hmm.
So here's hoping that the situation will improve. But yeah, this one, Tetrapodophis is not alone in this situation. Like there are a lot of Brazilian fossils that are in a similar boat where they were illegally taken to other countries, and the researchers from Brazil are not involved in their study. Yeah, it's a mess, but I do hope that you know people will start being more aware of these issues and putting pressure on relevant institutions and individuals to kind of make a change. Yeah.
Absolutely, and I agree. Um, so I guess this kind of brings us thirdly to our our next reason why Tetrapodophis is so controversial,
Mm-hmm.
and that's the fact that many paleontologists, who have been willing to study the specimen despite all of this, have questioned whether Tetrapodophis is really a snake at all,
Mm-hmm.
and not another one of these legless or almost legless lizards. So the particular paper here that I'm going to discuss by Michael Caldwell and colleagues is not the first such study to call its taxonomy into question. In fact, Caldwell had co-written a paper like the following year after its initial description, arguing that this animal had been misclassified and that some of the features of the skeleton didn't match that of known snakes, whether they were living or extinct. And so it's only now with this study that these authors were finally able to get kind of up close and personal with the specimen to make their determination. Because with that initial paper, like they said that it wasn't a snake. It probably wasn't a snake, but they weren't sure, just what it was then.
Mm-hmm.
So here we are. Now, of course, regarding the aforementioned controversies, the team had this to say, and I feel like I'm kind of siding with them on this, but you are more than welcome to interpret that how you will. While we recognize the complexity of the problem and the reasoning behind such sentiments, from our perspective, at this point, Tetrapodophis can no longer be ignored scientifically. A high profile journal announced its scientific importance as a four legged snake, resulting in broad consideration of the taxon in the scientific literature. And then they list like 8 papers here.
Mm-hmm.
And its wide recognition as a four legged snake in literally tens of thousands of popular science outlets in print and electronic media. The scientific and popular concept of Tetrapodophis exists, and if that concept is incorrect, then it remains open to correction or falsification using the tools and communication networks of science. And it's like, I mean, yeah, I get it. you know,
Mm-hmm.
um, as controversial as this fossil is, like it's a big deal, and it was made a big deal, and to kind of just say, well, let's just ignore this thing and pretend it never happened,
Mm-hmm.
like that paper trail is huge. so
Yeah. Mm.
you can't just hide that away or just dismiss it outright. Um, so I do think in this way, like I can kind of see where they were coming from, and I do kind of agree.
Yeah.
So I'm just kind of putting myself out there with that. But okay, so now they've been able to look at Tetrapodophis intimately, and they went about doing a complete resystematizing of the specimen. They gave it a new description. They plugged it into this massive phylogeny that combined both molecular and morphological data from both living and fossil taxa within squamata, particularly Toxicophera, and using both the Bayesian and the maximum parsimony analyses, which, if you remember Albert and I's little talk about that from the update special of Humanity, a Prologue,
Yep.
we don't have to
Mm.
get into that here again. So they did that, and there was even undescribed material that they needed to discuss. There were parts of the counter slab that left impressions of the bones from the opposite
Mm.
slab, and there were actually particular details here that were missed in the initial description. So they went and they went thoroughly through all of those. And so yeah, basically a complete 360 of Tetrapodophis was finally done. And yeah, their initial suggestions that the anatomy of this animal didn't match that of known snakes was well supported. Um, Everything from the skull, and the jaws, and the teeth, and on down the postcranial skeleton to the individual vertebrae and the ribs, parts of the remaining hind limbs. None of these really screamed snake to
Mm.
the authors. For a couple examples, the teeth on the dentary, so that's the front part of the mandible, are not positioned or shaped like those of the snake. They're sort of broadly rounded in shape, and they have a bigger root of dentine that you just don't see in snakes.
Mm.
They even had like skin impressions on the fossil. This is kind of fun, which they compared with other squamates. Now, these were originally interpreted as like belly and body scales, but these don't even appear to be like snake scales at
Mm.
all. In fact, like on a closer examination, the preservation didn't permit the authors to even call them scales
Huh.
at all.
Wow.
So, like that connection was out. So, with all this in mind, then, if Tetrapodophis wasn't a snake, what was it? Well, the big phylogenetic analysis that was done by Caldwell and colleagues did not place this animal among the snakes, and as suspected from their thorough anatomical investigation, placed it instead with a now extinct group of lizards called Dolichosauridae. Now, these lizards are not closely related to snakes. They are instead on the Mosasauria lineage. And like their larger ocean going relatives, Dolichosaurs were aquatic reptiles. They tended to be pretty small, reaching at most a meter in length, but many were really puny. I mean, if you couldn't tell by the
Oh
finger
yeah.
in the fossil photos on the slide, yeah, Tetrapodophis was puny too. And so, yeah, a lot of the skeletal features in this fossil point to an aquatic lifestyle, much like Dolichosaurus. The way the neural spines on the vertebrae are swayed back, the lack of an ossified mesopodium, which is a bone on the foot. On top of all of this, those gut contents with the specimen, um, while those were initially argued to be maybe some sort of frog or unknown squamate that lived on land, on closer examination, they could only identify one of those bones as belonging to a frog, but the rest were a lot closer in shape to a fish.
Mm.
So this guy was eating aquatic animals.
Mm-hmm.
And yeah, this is a far cry from the land dwelling fossorial snake that Tetrapodophis was originally described as. In fact, if you Google this animal and go to the images, you can see the initial James Brown piece
Mm.
that shows a land dwelling Tetrapodophis like just swallowing a lizard whole. And then you can now find the newer Julius Satani piece showing the animal swimming in the water going after fish. And of course, admittedly, yes, it still looks like a snake. But remember that there were several groups within the lizard clade that converged on the lengthy, mostly limbless body plan, and Luchasaurs were just one of them. They looked like water snakes, but they weren't snakes. So then, what does this mean regarding all that we had said about snake evolution? I mean, of course, we talked about the pendulum swinging towards the burrowing lifestyle, but the fact that Tetrapodophis is now kind of out of the picture, we can't really use it to say anything meaningful about snakes anymore. And, in fact, I was scanning the whole article. It's a big article. When I say a thorough investigation, it was thorough.
Mm.
Um, they didn't really make any comments beyond the simple statement that this isn't really a snake. So at least for now, um, whatever discourse there still is about the first snakes and what they were like, it's not going away anytime soon.
Mm-hmm.
Even if the pendulum has shifted, like we said, there's still some folks who are kind of holding out for snakes being aquatic originally
Mm-hmm.
idea.
Yep.
And you know what? The authors of this initial study, Dave Martell and colleagues, when those doubts were surfacing about this animal not being a snake, they were still pretty steadfast about it being
Oh
a
yeah.
snake. And I haven't seen any comments on them about this paper yet.
Mm-hmm.
Albert, I don't know if you know any, but um, so I don't know if like they still are like, nope, this is a snake.
Yeah, not that I've seen after this paper came out, but yeah, I do know that even very recently, like I think maybe earlier this year, I have seen authors from the original paper saying that yes, Tetrapodophis is definitely a snake. Don't listen to the naysayers and so on. So yeah.
Wow, that's funny. I mean, I can't see you looking at a fossil as thoroughly as this and still think that that original interpretation is sound. I mean, at least from my end of things,
Mm-hmm.
like their investigation was pretty good,
Yep.
and they made a very compelling case that this animal was not a snake. So, um, I tend to side with that for now.
Mm-hmm.
But if this isn't the last word on it, oh boy, I guess we'll keep an eye on it then.
Right.
Like we'll get the counter paper to this one, right? Where they're like, oh, actually, like all this stuff you looked at is wrong, and here's why. And, yeah, science is funny like that sometimes.
Mm-hmm.
Um, but hey, at the end of the day, at least we get to know a little bit more about deliciousaurs.
Yep. Mm.
So for every loss in science, there's usually at least a win.
Yep. Mm.
And so that's all I really have to say about Tetrapodophis and the world of snakes. Albert, do you have any kind of closing thoughts on all of this?
Sure, yeah, I have a few things. So first of all, I'm glad this study finally came out because I know it's like been gestating for a long time. I think the authors like first presented like an early version of the study, I don't know, several years ago, at the annual Society of Vertebrate Paleontology meeting. But yeah, finally, this paper came out, and that's good because I do think we were due for kind of a detailed restudy of this controversial specimen. And I do agree, like you do, with the authors that yeah, it's kind of a bit late to sweep this all under the rug. Like even if it's even if kind of the ethical even if there are like ethical issues surrounding like the specimen itself, I do think we can't really ignore it now that it has been published in the literature. So I am glad to see this alternate interpretation being out there, and I would agree that I'm not a squamate expert, so I don't know with great confidence like who's right or whatever. But I do agree with you that this does look like a very detailed study, and I am inclined to think that their interpretation is more likely to be correct than the original. Um, I do take a minor issue with one facet of their terminology, and that is the way that they use stem snake. So, as as I've explained before on the show, especially when talking about in the first episode of Dinosaurs, the second chapter, when I was explaining what stem groups and crown groups are, like kind of the original and currently most unambiguously applicable way of using the term stem group means that it is the entire extinct lineage that is, whose closest living relatives are a certain group. So, a stem crocodilian, like I mentioned earlier, is something whose closest living relatives are crocodilians, but is not a member of the modern group. So, Effigia earlier is, it's pretty distantly related from the modern crocodilians in the grand scheme of things. Like it branched away from its last common ancestor with them a long time ago, back in the late Triassic, or maybe earlier in the Triassic. But it is still a stem crocodilian because its closest living relatives are crocodilians, and so in I know it, at least from what I get the impression of from quickly skimming through the paper, is that in their analyses, the authors actually did find that mosasaurs and dolichosaurs, their closest living relatives are snakes, and like in the phylogeny that you showed on the previous slide, which is seems to be like gradually becoming like the current consensus regarding their relationships. And so technically, mosasaurs and dolichosaurids are still stem snakes. Now they're not very closely related to modern snakes, but they do still belong on that lineage because they're an extinct group whose closest living relatives are snakes. But that being said, that is just a kind of semantic issue because I do agree with them that, yeah, if Tetrapodophis is a dolichosaurid, and even if dolichosaurids and mosasaurs are stem snakes, they probably don't have that much to say about the actual ancestral condition of modern snakes. Like they could well be just a sort of independent foray into the water and don't have anything to do with the whatever common ancestor they shared with snakes. So yeah, no, I do take a small issue with that, but that's a minor thing. Obviously, I get the point that they're making, and I think that they did a pretty thorough job of that. And kind of the last thing is a sort of interesting thing. Yeah, you mentioned that for this paper, the authors commissioned a press art from Julius Chetney, a paleo artist, a very well known one, and I've met him at SVP a couple of times. He's a really nice guy. And where they showed their kind of their interpretation of Tetrapodophis as an aquatic animal and kind of swimming alongside fish and such. And in addition, also kind of showcasing the very small body size of this animal because in the new press art, you can clearly see that yeah, Tetrapodophis is a very small animal. Like various leaves next to it are massive and such. And that is interesting that they got Julius to do it because the original paper in 2015 by Martil and colleagues, they actually also commissioned Julius Chetney to do a reconstruction of Tetrapodophis for their paper, but following their interpretation. And so you can actually find, if you like Google Tetrapodophis, like the very original kind of press art that was also done by Julius Chetney, showing Tetrapodophis as a land-dwelling snake, and it is constricting a Mesozoic mammal, like a pretty decently sized one, and kind of in the process of swallowing it. And the authors, I think, in this paper actually kind of call that out and was like no, this thing is way too small to be doing anything like that. That mammal would be like it should be like massive compared to this this not a snake. And so they actually got the same artist to kind of redo a version that follows their interpretation, which I think is a lot of fun. And I do really like kind of the new art that Julius came up with for Tetrapodophis. It's really cool. I guess we should probably link to it in the description. Yeah, but yeah, I think those are the main points that I wanted to make. And so, yeah, if you want to close us off, feel free.
Sure. Okay. And I guess I apologize. Julius Chetney.
Well, to be honest, I'm not completely sure either, but that's the way I've heard other people say it.
Okay. Okay.
Yeah.
Well, Julius, if you happen to be listening to us by chance, we apologize in advance.
Yes, yes.
Um,
Sorry.
uh, but it's all good. I mean, definitely, Julius is a great paleo artist.
Oh,
I
yeah.
Probably one of my favorites in terms of like the moderns. Um, just I love the vibrancy of those pieces, and it kind of like it emphasizes like, oh, a lot of animals in the world today are like super colorful and
Yeah.
they're doing really interesting things. And so why would it be different in prehistory? You know, with fossil animals. So just all good things.
Oh, yeah.
Um, but yeah, definitely. Wonderful paper. I'm sure we'll be hearing more about it in the future. But yes, that is it for the show. If we move on to our next slide, of course, this is our reminder that
Mm.
we are going to have our first interview coming soon, to be determined, with Miles Greb and Trey the Explainer, two wonderful individuals who have done quite a lot in terms of like science communication and natural history,
Oh yeah.
media. Um, of course, we can go on and on about them, but of course, you can go to our review episode of The Dawn of Everything to kind of get our little biographies for them. Yes, we are still planning on doing that. Trey is still uh, doing classes, and I've been in contact with him, and he's just finished up a couple of exams. So I have a sneaking suspicion that we'll probably get some definitive dates fairly soon.
Mm-hmm.
And when we do, we will definitely let you all know. But for now, we are also asking again if you have any questions you'd like to ask either or both of them. Please send them in. You can leave a comment here on YouTube. You can email us on our email, which we'll give momentarily. You can go on our Twitter page and you can leave comments there as well when we share this episode, or the message that I put earlier with their avatars in there.
Mm-hmm.
Um, and yeah, you can ask whatever you like within reason, of course. But I will definitely mention, as I guess to make my job a little bit easier, um, if you have like more specific questions for either or both of them, if you could prioritize those, I think that would be kind of
Mm-hmm.
nice. If you have a question, kind of like, you know, like, how did you create, the Trade the Explainer YouTube? I mean, like we were kind of gonna ask them that anyway. Sort of a sort of like our usual interview. So yeah, like that's just a minor aside
Right.
there. But yeah, we're definitely very much looking forward to this, and we have it in good word that they're very much looking forward to this too. And so I'm definitely very excited for
Mm-hmm.
our first interview. But yes, so if we go to the next slide, we are also on Patreon. If you'd like to consider supporting us by donating to our Patreon, that's patreon.com/time and clades. We would very much appreciate it. Of course, your contributions, however small, will help us continue this series and develop new projects and expansions. And of course, we currently have two patrons at the moment, including my sister Juliet, who is due for her shout out. So,
Mm-hmm.
hey, Jewel, thanks for your support. We appreciate it. And yes, of course, with our general acknowledgments, we'd like to thank our good friends Henry and Alicia for their contributions to this series. Henry, of course, made the very catchy opening music
Mm-hmm.
for our show, and Alicia made the color scheme for Albert's Alvosaur avatar.
Yep.
Blech, I messed that up a little bit.
It's all right.
um, but yeah, so we appreciate that very much. And of course, you can follow us on our Twitter for updates. We are at Time and Clades, where we usually upload videos and give small announcements here and there. Most likely, you are watching us on our YouTube page through Time and Clades. Feel free to um, subscribe and follow our channel for more videos in the future, of course. If you have any questions for us, for example, questions for Miles and Trey, like you said, you can comment on our YouTube comment section, or you can go to our email, timeandclades@gmail.com, and we will certainly get those as soon as possible. And of course, if you want to get references for the papers that we talked about on our news episode, among other things, you can go to our description for those relevant links. And with that, yeah, that is our show. Um, as far as upcoming things, I don't know, Albert, what do you have to say about that?
Yeah. Well, what I can say is that this is not going to be our final episode of the year, so there will be a few more coming, actually. So, of course, we do have the interview with Miles and Trey at some point this month, so we'll probably be releasing that before the year is over, once we have a set date for it. And actually, speaking of that, I noticed just earlier that Trey's avatar actually is a Ceratosaurus, which we happened to mention in this episode. So that's kind of an interesting, fun coincidence. Yep. And the other thing is, we'll release at least one more episode in addition to the interview later this month. And so for that episode, we kind of have something special, or rather, I should say, another special thing planned for it. It's going to be something kind of different from what we've done, at any point before. Basically, both of us are going to be reviewing a TV show that we both watched this year, and yeah, I think I'll say no more than that for now, but have fun guessing what it might be.
Oh yeah, definitely looking forward to that too. But yeah, we'll keep that under wraps for now. But yeah, definitely expect that within the next week.
Yeah.
Um, we're definitely looking forward to presenting that to you all. But yeah, we thank you all so much for joining us, and we wish you all wonderful days ahead.
Indeed. Take care, everybody.